Scooby's getting tired. You ready to go home? Are you ready to go home? Is that tripod in your way? Was that in your way? Oh, you want to eat me, huh? Scooby's trying to eat me. Yeah, Scooby's going to eat me. Yeah, that's right. All right, get down. Come on, get off the bench. Come on, get off the bench. You're not supposed to be up there. Come on, down. Good boy. Yeah, that's a good boy. All right, look out. We got work to do. Scooby's interfering in my work. In my way. All right. We have linkers to work with. So he didn't like my carburetor I put on the 65 that my dad rebuilt. So I went through his junk pile over here. And this one's a complete one that looked halfway decent, so I left it together. So all this other stuff we took apart. And then we took and blasted everything to make it look pretty. So these are all the parts how they come back after being blasted. You can see all the damage that's been done to them. So it's a little bit thin over through here, but I think it'll be alright. Oh, my light's on or not. It is now. These are all the small parts. And these are the bodies. Let Scooby see this, he'll eat it. There it is. Alright, so there's our three bodies to play with. These are all M74Bs. These are too shiny to have the light on now. Rid of the lights, you can see. Yep, M74B. And another one. This one's got some other writing. DJ. BDJ. I don't know what that means. It means something to somebody, I'm sure. Overall, all these bodies look pretty good. This one has a broken off screw head in there, but it doesn't really matter. We just put the jet on this side. So these are all the parts that got cleaned. So small parts. I even cleaned the pan out, it was all rusty. It's actually a steel can. Hard to believe. Look at the beads there. See the beads? Those are beads. So these are all the little jets and stuff here. I usually solder these things up and re-poke the hole. So this stuff, all this stuff needs to be worked on. Like I said, these ones probably should be soldered on. Where's the other one at? It's not good. 3. There's the other one. So, do they all look the same? They all look pretty close to me. Ooh, I think that helped or hurt. Alright, so we're going to go see what size these are. So we know what they are. So I'm going to put that tripod in the way. Who was that? Now, usually on a S&S carburetor, you run a 68 to a 70 usually. 72 is usually pretty big for a main jet. Being a linkered, which is a lower performance motor, you would think it'd be smaller than that. But you'd probably be wrong. There you go. That has an 81 thousandths jet in it right there. 81 thousandths. So these are too stinking big to run a linkered on. We're not running 1965 gasoline anymore. Now if you're using racing gas, that's about the closest thing you got to fuel we had back in the day. And even that is probably still going to be too rich for you. And we still have the needle to play with after it flows through this. So this one's pretty loose. So usually what I do is I take these, I solder up the hole, and then we drop it down to something that's probably more down here in the 50s area. And then I can use the adjustable needle to bring me back up to the, anywhere from the mid-60s to 70s area. So, something down like this 52 works pretty good, I think. 55, something small. So 81 is a little bit ridiculous. And it's going to make your bike run really, really rich all the time. And you can't do anything about it because it has a big ass hole in the side of it. Trying tripod's in the way. Here, on that box there. So, these are your main wheel through here. So you have two holes here. One gets plugged and one has a jet in it. Usually the jet goes on this side where they get the plug. Doesn't matter which one goes where. It just has to go in your someplace. On the older carburetors, you don't even have a jet. It just plugs solid. And most of the time, you can get away with that. The high-speed needle, which we don't have any sitting here. These are all the parts we had. Zinc, this is all CAD plated aircraft mil spec CAD plating. You think chrome plating is expensive? Wait until you do this crap. I had an aircraft restorer do this for me. I didn't realize it was going to cost 10 times more. Where's all the jets at? I don't even see the needles in here. There's some needles right here. So there's lots of paperwork telling them exactly the baking time, how many thousandths of buildup you got, mil thickness, and right down to the gnat's ass. I have no doubt that this stuff's going to stay on there for just about forever, but damn, it sure costs a lot of money. And it looks like chrome, even though that's zinc. Or no, I mean, this was CAD plated. It's supposed to be CAD. Looks like nickel to me, but it's supposed to be CAD plated. Sure does look like nickel. But anyway, it's pretty damn bright. So anyway, this has a tall needle on it, it's skinny. You know, a tall taper, let's put it that way. So this one here, when you put this into the hole, it's right here. That's your adjustable main jet hole right down there, a little small one. Because this needle here goes down through there. And rotate that on in there. And see how it goes down into that little small little hole down there. Like that. And it plugs it up. So when you come out your turn and a half to 2 turns, there's half, 1, 1.5, 2, which is a lot. Usually only like 1.5, 1 3/4. That's how much of the hole is actually open when you do that. Right there. So not too much. Now in the older carburetors, they had a blunt needle with a bigger hole over here. So when you opened up just one click or so, it made a big difference. When you got these carburetors, you open up a click or 2 or 3 clicks, it doesn't really do a lot. It does make a difference, but not a huge number. So that's why in the old carburetors you don't need the jet over here, because it has a pretty coarse adjustment, opens up a big hole real quick. So you can get away with doing stuff differently. So that's why I take the jets on these ones, I plug them up and make about half the size. And let the needle do the rest of it like it's supposed to. Alright, so next problem is we got to see how bad these things are worn. Now see how they get worn right here from the butterfly? That's from this part here eating on it from vibration, going back and it's all the time. So what I go in here and see, I solder that up to get rid of it. Now, it's only on that one side. This one's pretty smooth, and this is pretty good on the bottom. These bodies weren't too bad. This one has on a little bit on both sides, and not too bad. Something's going on over here though. They got, I don't know what they did there. It's pretty rough looking. You can see how it comes up to this far on this one, a little bit deeper. And this one over here, you can see the wear mark that's in there pretty well all up to here. So this one's pretty deep. So this one here is our better carburetor right here. Doesn't hardly have anything over here you can see. Anyway, I solder this up and I recut the hole and make that better. Now, the bike over there that has that carburation issue right off of idle, right there, is attributed to when you first open the butterfly up, you're letting the air leak through here instead of coming through your transfer slot right over here. That's your transfer slot. And see, the butterfly has its cutaway on it. So as it opens up that slot, you get more fuel through that thing. So to correct that problem, I either have to open up this, I got to make the bigger hole on the left bigger, or I got to lengthen the slot further up to get more fuel into the bike. The problem is once you do anything in that, you cannot reverse it. So I have destroyed more than one carburetor by screwing with that stuff. You can come back and solder things up and try to save it, but it's pretty hard to do. So these used to be really cheap, so it didn't matter, you just throw in the junk pile, but now we actually try to use these things. So see that thread right there doesn't look too good. That looks like it's getting ready to be a helicoil job. Looks like they cross-threaded it. Something going on there. Alright, so this one here I'm going to go ahead and try to solder these up. So to do that, I'm going to go back and try to do some soldering. And we do that with a torch. I'm going to need my tripod for that. So I'm going to take all of this junk, and we're going to the back room. So we'll be back. Okay, we're going to do a little bit of soldering here. So we're going to use regular 1/8 inch solder lead, whatever you want to call it. I call it solder. So we're going to use that. We're going to put a little flux on there and heat up with a torch and make it go. So the best flux in the world is this Everflux, whatever the hell this crap is. Anyway, it works really good. You figure out how long it works. So basically, you just you take an acid brush like that, and you kind of put it where you want it to go. Preferably not where the area you don't want it to go. And that's what you do. It's the only flux I've used that you can still buy that works. I had some other stuff I used to use back in the early 80s that was hard to get, but that's all you can get. It's acid flux, so it will tarnish this, but the heat's going to do it anyway after we bead blast the body anyway. So it doesn't matter. So I'm just about out of argon over here, but we can still do some welding. Okay, I use a real small tip on here. Not super small, but small enough. And you don't want to put the heat right on the body we're going to work. You want to put it on the back side of the body. So you just heat it up. When the flux starts to go away like that, you're good. And you just kind of lay the solder in there and try to put it in. Now if you're really, really careful, you can put the solder exactly where you want it and build it up. That's pretty hard to do. So you're letting the tongue do it. A little bubbling going, but no melting. Yep, we're starting to get some activity now. Yep. Okay. Just to heat where I want it. Put it down there to catch the fire. Get my welding gloves on so I can pick the body up. Okay. So you can see how I got the in there kind of where I wanted it. Now I want to stand a little bit more angle on it. I'm going to try to melt it, but not where, only on the very bottom, not the whole side of the body. So once you see the solder start to melt, you got to get the hell out of there as quick as you can. It's just starting to melt. Put it right where I wanted it, and no extra. See, I put it right next to the hole right there. Whoop. Right next to the hole. Okay, now I'm going to try to, there's a slot, for some reason cutting the body right on the top. Heat that up right here. Can't see anything I'm doing, I don't think. Yeah, it's hard to work a torch and a camera at the same time. The light's on, but you sure can't see anything. Okay, so let's see if we can get this to do what I want. Now, if you put too much heat in, all that stuff I put up on the body will melt off. So we'll just heat right where we want to do it at. We don't want to put a lot of it where it goes down the bushing. Okay, you see how it just melted right there? See how the heat retains because it heats up a thick area. So you got to watch out how thick of an area you're heating. So it took a lot of time for that to go dissipate. Okay, now this one here, I don't remember if there's anything on the side of the body over here. So let's open this up a little bit further. Put a little acid right over here. It's pretty hot still. Okay, I'm going to put a little bit of fluid, or a little bit right over here, just in case there's something over here. I don't think there was, but nowadays I have a way of getting this out of here pretty easy, so I can put a little extra on there and not worry about it. Like in the old days I had to be very, very cautious how much I put on there because it's hard to get it out. Start to melt. Keep putting heat in until it melts. Yep, right there, starting now. Just starting. There we go. Okay, just in case there was a little bit of something there, I put a little extra right there. Alright, so that's how you do it. And if you had to do it on both sides, you do it on both. So this one we need that. And you see how you discolored the body? Oop. I am nowhere near where you can even remotely see. Okay, you see how I discolored the body, so I got to re-blast it. And you can see where I put the solder in there. Alright. It's kind of warm in my hand, so I got my glove on. Alright, I grab the next one. This one's cold. Okay, so we look to see what we got to do. Looks good on that side. This has got both sides I got to do a little bit on. And about how far up we need to go. So not quite the transfer slot, but close to it. If you want to tighten the vise too much, you'll do some damage to the body, so be careful. Okay, so I'm going to put a little bit of this up in there like we need it. This one does not have the big groove in the front to worry about. Okay, so we're going to heat this up on the back side and blow this up now. Okay, so we're going to heat it up from over here. Of course, now the damn camera's in my way. So you can see where the heat's going to be by where it's burning it away right now. There we go. See how it melts away really quick? Okay, see I put it only where I wanted it. Okay, if I do it just right, I should be able to heat it up on this side. I heat more toward the top of the hole, not the base. So the heat's going to transfer from the top down. So it's only going to melt the part I want to melt. Oops, see right there, it only melted where I wanted to. Yep, let that fall in. Yep, too much. Okay, so you can control where you got the heat at. See, I go to the other side over here. Put a flux over here. I didn't do this side. That's going to be more trickier because I got the vices blocking the whole damn thing, I think. Don't have good access to where I want the heat to be right now. I'm not exactly sure where it's going to be hot. Well, I can see where it's going to be hot now. Alright. Okay, lift it up a little bit. I'm not sure I'm going to do that, so I'm going to heat the front up here and let the heat kind of wick in. Oop, wasted that piece of lead. There, we're just starting a little heat there. So the whole solder is getting hot. The heat's coming through the top of the hole, not through the body. Okay, there, it just flowed down there. See right there? It just flowed. Okay, so put a little extra right there. Damn it! See, I'm wasting more solder than doing anything with. Alright, that's enough. Don't have a good spot where I can get to the heat where I want it. So I wasted about 1.5 inches of solder there. This is expensive in California. You can't just buy it anywhere. You got to buy it from Old Farts. You got to get from out of state. I just get it from Old Farts that have lots of it and get rid of it. I'm their hazmat area. I get rid of it for them. Okay, let me get the other body. Way over there. Okay, how bad is this one? So this one here, just right on the very bottom and then up the side a little bit like the other ones are. Way too much goop in there, but it's okay. And see, I'm using contaminated solder. See all the rust and corrosion on it? With this flux, it doesn't care. It still works just fine. First you bubble it away, and then that's the water. Come in there with the heat. Come on, start melting. Getting soft. There, it's starting to transfer a little bit. Oop. Okay, just put it where I want it. No extra. Come on, starting to melt, starting to melt. There we go. Starting to melt too much. See, you just put it right where you want it, and get the hell out of there before it changes. Okay, I'll go from the other side now. Use my other hand. This one here I only want to do right on the very bottom. Right in there. Whoa. Yeah, you can go up a little bit higher than that. Not much though. There you go. That's a little bit too hot. It just drains to the bottom. But you get the idea. And once it sets up, you can move it. So there you go. Like I said, you got good control of where you're doing it. You're just heating out here on the outside in different spots, depending on where it needs to be. Different parts do different heat bill. If you watch how the heat kind of goes to the area, and you can control it pretty good. You got to be careful. The trick is a real long tongue flame, and you're not heating way down here where all the heat is. You're heating way up here at the end of the flame, where there's no heat. There's not a lot of heat up here. Heat's way down there. So you're working up in this area here. That way you can control it really good. Alright, so that's how you do that. If there's any other issues with the body, you can, any holes or porosity, you can do the same thing. You solder it up. I'm going to take care of the body. Okay, now I'm going to go over here and work on these jets. So the problem with jets is you don't want to screw up the threads too much. So, get over here where I'm at. So there's my jets. Of course, I'm using a really big solder, which you shouldn't be doing. Okay, the only thing I can't fix on this is the threads. So I can't do anything about these threads. When these threads are filled up full of crap, I'm done. So if I put solder from the top, it'll probably go in the thread. If I flip it upside down, it'll fill in the slot, but I can cut the slot again. So I'm going to go ahead and just stand these things up here. Get them far enough apart that they don't interfere with each other. Like that. And we're just going to heat them up and do it. Probably should not. I'm not going to put the solder or the flux on the thing. I don't want to do that. Okay, so this is just going to get this hot. That's hot. Too much. I'm not sure if that's soaking in or not. Hard to tell. Get a little water on there. Oh yeah. She's fully soldered up. It's over soldered. Get my pair of pliers, I'll get rid of that extra solder. Okay, I'm going to do this here. I'll do the same thing. When it starts to turn color, its color's good. A little bit darker than that. It's fully soldered. Okay, my pliers are in here. There we go. Got big ass pliers. Go ahead and cool these down. That one was hot. Alright, so now they're cooled off. See how the solder's right to the base where I want it to be. And what I want to do is I want to get rid of the excess right here on the tip. But I want to melt all of it away. I only want the tip away. Okay. So we still got the hole filled on that side, but we took off most of it on the outside, so I don't have as much work. That's a good one. Same thing on this one. That one did not weld all the way through. See, it's got a hole still in there. So that one I failed to do correctly. So I'm going to heat that thing up more. Try to get the solder to go down. Not sure why it's not going down. As far as that one's going to go. Maybe I should put flux on these, but I don't really want to. Okay, what did this one do? This one didn't work very good. When I dropped in the water, it all came out. It's not a very good solder job. So this might not be working the best. It's easy I use my soldering iron, but I'm trying to do it differently. This one looks good. So we got one that works, so maybe it's just not sticking very well. You always have that problem. No bond. Dirty asshole. Stuff like that probably going on. That might be the problem. Yeah, that didn't work on that one either. Alright, I don't think this is working very good on these, so I go ahead and melt all this solder out of here. It's soldered good from that direction now. There we go. It's already cleared. And I have my doubts about this one being any good now, so I'm just going to go ahead and melt it away. Alright, so this one's all emptied out too. So we're going to call that a failure. We get those around here. Okay, so now we got these cooled off. Pull this back a little bit. Alright, my guess is they're probably pretty damn nasty on the inside of that hole. Nobody cleaned it, so I'm guessing that's probably the problem. Alright, so I'm going to go take these and run the drill up and down here a few times, clean them out, and we'll be back. Turn the torch off. Alright, I'll be back. Okay, we're back. Plan B. If that don't work, we'll go to C. Okay, so I cleaned out the holes. I got me a paper clip. Take some flux. Put on the paper clip. Right there. Stick inside the hole here. Snot her up pretty good. So it's all snotted up really nice on there. We'll lay that on top of the table here. We'll try that. I think that might have a better results than we did the first time. At least I hope it does. This flux really does work good, so having some on there is going to have to make a difference. Okay, I think I got it snotted up pretty good. Okay, let's move solder out. Get our torch going again. Definitely cooling off around here. Winter time here and it's 9:30 at night and we got no shirt on, short sleeve Harley Tatro shirt. It's another one of those 80-degree days today. It's our normal weather around here. Of course we get to pay all them good taxes to live in this weather. So there you go. Okay, we're going to heat this up a little bit, try to stay off the part that matters. Damn it. There we go. That seems to be working a lot better. Perfect. Even heard gurgle. flux really makes a difference. There we go. That last little bit was too much, but oh well. Alright. I think that worked a lot better this time. Now, just a matter of let these cool off enough that I can do something with them. Okay, that's stuck to the table. Not quite all the way through. Dimpled good. Dimpled good. Yeah, a little bit of a dimple, but good. Okay, now I'm going to try to melt off just the excess on top here, which I don't think I'll be able to do without losing what I don't want to lose. Yeah, it's not going to work. Yeah, I just melted the ID out. See, we're trying to keep in the thin part, and we're heating up the thick part, so it kind of defeats the purpose of what's going on. There we go. See how that works. So we're just going to have to cut away the top. Hot, hot, hot. And solder back on the tip again. Okay, well, the biggest thing is I did not solder the thread up. That's the part I can't fix. Not very easily. Okay. Let's see how hot this is going to be. It's going to be quick. Yeah. Get the water out. How about the jet? They're out. Okay, so there's the jet. So a little bit of cleaning to do on the top. Nice good solder joint. That's nice and good bonding all the way through the whole thing. That's nice. So the other one I think might have fell out and would come out. So this one here is a lot better. I only got it just in the very center of the hole. And then a little bit of a dimple here, but that's mainly flux. So perfect. And then this one here. Get a little more carried away with this one. And it's soldered all the way to the bottom. It's right on the edge of the thread, but it didn't go in the thread, I don't think, so that's good. Alright, so that's how you solder those up. So the trick is the flux. So like I said, this is the stuff that works. This has been old, sitting around for a year or so, and it's getting all dry. I put water back in it and reuse it. So it still works. But you do have to clean everything off. It is acid core. So I'm going to take the carburetors and go over the sink and wash these out with water. Get them cleaned up and I'll go blast them. So we'll show you what they look like tomorrow. That's it for tonight.